All right, y'all. We're taking a look right now at the topic 14 notes, the second section of them, wherein we're talking about surface area. And on this page right here, there's just one blank to fill in. It says that a net is a plane figure, so it's a two-dimensional figure that can be folded to make a solid. Okay, a solid being a three-dimensional figure, the things that we've been talking about in topic 14, like a prism or a pyramid or something of that nature. Okay. Um, the examples that it gives right here, the examples that it gives right here are a cube and a rectangular prism up at the top. Okay, a net is just if you like if you had a box that was a cube and you cut all of the seams of that box and unfolded it out all out. This is what that would look like. Okay, this square right here is what that would look like. Same thing on a rectangular prism. You can see that you've got a top and bottom base, and when you unfold that prism, this is what it looks like. And so the reason that we're looking at all of these, the reason that we're looking at all of these nets here, is to show you that what we're talking about today is not some nonsensical thing that we're just making up out of nowhere. Um, you can see when you look at these two, when you look at this page, you can see how, if you did this is something you might have done probably in sixth or seventh grade. You could have cut something like this out and then folded on the dotted lines, and it would make a cube. Same thing if you cut this out and fold it on the dotted lines, it would make this triangular prism right here. Okay. Um, it's a pretty common activity in your middle school math classes. And so when we look at this right here, the reason we're looking at these nets is because that is one way that you can find the surface area of a 3D object. You can find the area of its net or find the sum of the area of all of the faces that make up that net. Okay, this example right here has a wooden cube. Is a cube with sides that are 5 centimeters long each. Well, you see a bunch of 25s in here. Okay, the reason that those are there is because you have to remember that all of these edges are all five. Okay, and so if we're looking for the area of this one square right here, it's 5 by 5. It's a 5 by 5 square, so that's 25 square centimeters. Well, that's the thing, is that all of these squares are all 5 by 5 squares all the way around this whole entire thing. So if we're looking for the surface area of the cube, we can just find the area of this net. And this net right here is another version of it. It's already drawn on your paper. Every single one of these is all 25 square centimeters. So if we're looking for the surface area of this cube, it's just 6 times 25. All of them are 25 square centimeters, and there's 6 squares. So our surface area ends up being 150 square centimeters. And that also shows us what the formula is. Okay, this right here is a formula for a surface area of cubes. Okay, it's also written on the back wall here in the classroom. It's written on the back wall: 6 times the edge length squared is the surface area of a cube. Okay, that's something that would work for any cube. There's also, as we look at this, our next example is not a cube, but it's a rectangular prism. So I like this picture. I like this diagram because it's all color coded. Okay, if you unfolded this box right here and flattened it all out, the top and bottom are the green are represented. The top and bottom of this box are the green rectangles. The front and back of this box are the purple ones, and the left and right side of this box are the red ones. And as you look at it all, and we're using 12-inch length, 8-inch width, and 4-inch height, it unfolds and looks like this. And so if we can find the area of all of the parts of this net, that would be the same surface area as this prism right here. All right. So this first box, this green one up on top, is an 8 by 12 box. We multiply 8 times 12, and that gives us an area of 96. This green one down here is the same. It is also 96. The purple one here is going to be 12 across, and it's going to be 4 inches up and down. So 12 by 4 gives us an area of 48. That means this other purple one is also 48. This red one is 8 by 4, so it'll be 32. And that's 32. Okay? All you have to do is add up all of the different parts, add up all the areas of the different parts of this rectangular prism, and we get our surface area. All right. So the problem you may run into is that sometimes you've got a picture of the prism like that, or you've got information about the prism, but you don't have a net. Okay. And drawing a net of a prism can sometimes be kind of a difficult process. So here is a formula that you can use for the surface area on a rectangular prism. Okay. On that previous problem, our length was 12, our width was it 10? Our width was 8 and our height was 4. So if we plug all of those in, 2LW, 2 times L times H, 2 times W times H, length, width, and height. All right. We just plug all that stuff in and look what happens. Okay. When we start simplifying it down, we've got 2 times 96, 2 times 48, and 2 times 32. Look at what we just added up. We had 2 squares that were 96, 2 that were 48, and 2 that were 32. Okay. What it's telling us is that this formula right here is exactly the same as if we were adding up all of those individual rectangles. And so we get exactly the same answer as well. All right, that's what we got on those. For these next two problems, problems A and B under guided practice, I want you to pause the video and look at them yourself. Okay, try those problems out yourself, and you can pause the video right now and come back and then check your answer. All right, here's the answer for problem A. Okay, we're doing 6 times the edge squared if we're doing that formula. So 6 by 6 is our edge, 6 squared. So it's 6 times 36 gives us a total surface area of 216. The other way you could have done this was by noticing on this net that each square would be 36. And you're going 36 plus 36 plus 36, all for all 6 of those squares. So you do 6 times 36. It's exactly the same as going by that formula. Go on to problem B. Problem B, if you plug in your length, width, and height into the formula, this is how it turns out. 2 times 35, 2 times 70, 2 times 50. Okay, guess what, y'all? If you were finding the area of these rectangles, this one would be 35. This one would be 70. And this one would be 50. And look at it. You've got 2 35s, you've got 2 70s, and you've got 2 50s. Okay, just like the formula says. All right, we're going to move on now to our next part, which is the surface area of prisms and pyramids. Okay, a triangular prism, something to remember here is that you've got 3 rectangular faces and 2 triangular bases. Okay, the reason that we're pointing this out, this is something you already know. Okay, everybody knows what a triangular prism looks like. The reason we're bringing this up is to remind you that if we're trying to find the surface area, you will have to find all of the areas of both of the bases and all of the rectangles that connect the bases together. Okay? You could have a triangular prism. You could have a hexagonal prism. You could find on one of your assignment problems is going to be a trapezoidal prism. Okay, you have to find, if you're going to find the surface area, you have to find the area of both bases and then find the area of all of the rectangle faces that connect them together. Okay, look at this example right here. When we're looking at finding everything involved with a triangular prism, okay, we're going to have to find the area of both of our bases. So I'm looking at these 2 triangles right here. As we look at the net, okay, as we look at our original prism over here, it's this front triangle and this back triangle. Those are the 2 bases, okay? If we're doing the area of a triangle, that's BH over 2. That's something we're very familiar with at this point. So 1/2 of BH is 6, 1/2 of 6 times 4, which gives us each of those triangles, the area of the triangle is 12, all right? Both of those triangles are going to have an area of 12. Now, you can see it on this diagram. That these purple rectangles are representing the faces. One of them that's kind of on the front of this prism, and one of them is on the back side of this prism that we can't see right now. Okay, that's what these 2 purple rectangles are. Both of them are 5 centimeters long. That's based on the slant height right here, and they're 11 centimeters. They're 5 centimeters wide based on that slant height, and 11 centimeters long. Okay, and that's based on how far apart these two triangles are from each other. They're 11 centimeters going down the whole length of the prism right there. So each of those purple ones is going to be 55 because it's 11 times 5. And this last one right here, this red rectangle is the bottom of this prism. Okay, it's what this prism is sitting on top of. It's 6 wide and 11 long. So 66 is our area for that one. We add up all of those pieces. We've got two 55s and two 12s and 166. We add everything up and we get a total surface area of 200. Our next example is a pyramid. Pyramid has got this, in this case, a square base. It measures 10 inches on each side. It's got 4 faces, and they are all congruent triangles with a height of 12, so that's good. The height of each triangle is 12. That's what it said. So if we're looking for the area of this whole entire thing, okay, the area of this net is equal to the surface area of this pyramid. So we'll start with these triangles. Okay, the area of a triangle is BH over 2. We already know that. 1/2 times base times height. Well, the base going across the bottom is 10. The height is going to be 12. So 1/2 of 10 times 12 means each of these 4 triangles right here, all of them are going to be an area of 60. Okay, the other thing that we need is the area of the base. Okay, the base of this rectangle is a 10-inch square. So if we're going for the area of this, we'll go 10 times 10, which is 100. Okay, so if we're adding up all the surface area, we've got 4 of those triangles that are all 60, and the base of the pyramid is 10 squared, 100. 240 plus 100 gives a total of 340 square inches. Later on in the week, in section 4 of these notes, we are going to be talking more about surface area of pyramids. So don't get super bogged down if you don't quite understand this right here. Okay, we've got 2 more guided examples. I want y'all to take a second and try these out on your own, and pause the video right now and then come back and check your answers. All right, here's our answer on the first one. We've got a surface area total of 330, and the way that we got that was by finding the area of both of these triangles. Okay, both of these triangles, we do BH over 2, so that's 5 times 12 divided by 2. Both of those triangles are each 30. And then you look at this prism. The skinniest rectangle down here is the one that's on the bottom that the prism is sitting on top of. It's 5 centimeters across, 9 centimeters long. So that's an area of 45. This purple one is the one that's on the front of the prism that you can see right here. This slant is 13, so the rectangle is 13 by 9, which is a total of 117. And then our last one, it's on the back side of this diagram right here. It's in line with this, so it's 12 by 9, which is 108. We add up all of those pieces, it gives us a total of 330. Our last pyramid right here, it is an equilateral triangle. Okay, so we find the area of this base, and then we find the area of all 3 of these other triangles. Okay, the area of this base, BH over 2, so 1/2 times 6 times 5.2 for just the middle triangle right there. That would be 15.6. If we're looking at the faces, each of them is going to be 6 times 10 cut in half. So 1/2 of 6 times 10 is 30. Okay, and we've got 3 of these. So that means our total surface area is going to be our base, 15.6, plus 3 of these 30s, 3 times 30. So our total surface area is 105.6. All right, as you're working on your canvas, let me know if you've got any problems. We'll see if we can get it sorted out. All right, y'all have a good one.